enjoying your college life, it didn't literally mean like, you just keep bunking the classes and go out and have fun, but actually participating in a lot of extracurricular stuff. Important thing, once you get into the corporate world and start building things for real, you need user feedback, right? That tells you how to shape your product, how to build things. Even back then, like, the scale at which Amazon kind of processed stuff was significantly ahead of many other companies. There were only a few companies which could match up that kind of scale. Like in the early days, sure, you can experiment, you can try a few things before you find where your kind of passion lies. But then at some point, a few years into your career, you have to be very intentional in how you want to grow and learn. They're actually massively very different platforms, right? Like for Spotify, it's primarily a subscription-based platform. YouTube, it's more ads-based. But largely, like the way ad targeting works is that, ads are usually served at certain intervals based on different kinds of rules for how you want to engage with the users. You don't want to like, pester them with too many ads that you lose the engagement. You learn the most by doing, and I truly believe in that. So like get started, even if it's a small thing. You don't have to build some massive new product, right? Like pick up a side project, play around with these models. And these days it's much easier, like it happens by trying to fundamentally solve things. And, the lagging indicator is that it was a breakthrough or it was like something exciting. Seek good mentors, and mentorship is not like people giving generic advice or reading management books and telling you things. People who can actually like, reason with you about your situation, can be a sounding board as you're navigating different career choices, technology choices, whatever else it is, right?
Hey everyone, welcome to Breaking into BigTech, a podcast by Somaya Machine Learning Research Association, part of KJSSE School of Engineering. I'm your host Ranbir with my co-host Chirayu. Today on the podcast, we have Kinshuk Mishra sir, who is a technological leader who has scaled and built products for companies like YouTube, Amazon, and Spotify, and is currently bringing in AI-driven innovations in the healthcare industry. He's a rare mix of deep engineering experience and thoughtful leadership. So let's dive into it.
The first question we wanted to ask you, how was your college life or your academic life from the start as a whole? Like, were you in the toppers or you were like a backbencher kind of person on medium? And how was those subjects treating you in college, then your masters, etc.?
Yeah. So firstly, like, thanks for having me on the podcast. Hopefully I can share some insights which could be valuable to, other students at Somaya. I would sort of say that I was someone who was, always in the top percentile, cared a lot about studying, but I was never a first bencher. I tried to strive for the right balance of like enjoying the college life and also like, making the most of like the education you get, primarily because and this is maybe a valuable lesson to all of you. Like a lot of the friends you make during your college days will stick around for a long time because you're at a stage where more or less everybody will end up in the same kind of profession, right? Like regardless of whatever you pursue next. So there's a lot of like common ground with the friends you make during your college days, and those friendships last because they're unconditional. So do take the time to like, enjoy the college life. But at the same time, I obviously was very focused in getting good grades, sort of being focused on learning the right things, which also like, developed a lot of curiosity and interest in actually learning about artificial intelligence way back, like, sort of dating myself 20 years ago, when it wasn't even like, popular field these days, like it is these days. So ended up pursuing my master's, after my undergrad in Somaya, came to Georgia Tech for my master's. It was master's in computer science, but I did a lot of research in game artificial intelligence using some of the techniques, which are still relevant today, like reinforcement learning, but few other techniques. And it was a great sort of experience, having transitioned from India, where I don't know how things are these days, but back in the day, there was a lot of theoretical learning. But what sort of, my master's gave me exposure to was a lot of practical learning, because here you do a lot and you sort of learn by doing things, by actually building games, by building different kinds of software, like experimenting with different kinds of techniques of just like, building things. And that exposure was very helpful. One of the few activities, sort of going back to Somaya days, I don't know if you guys still run the robotics competition. That was one of the most fun activities, right? But when I meant like enjoying your college life, it didn't literally mean like, you just keep bunking the classes and go out and have fun, but actually participating in a lot of extracurricular stuff. A lot of my friends and I, we would participate in these annual robotics competition, actually build a lot of like these cool applications to control robot remotely with whatever resources we could. And I think those are the kinds of things, which shaped how I thought about building things. And unlike a lot of my friends who ended up going and doing MBA and pursued more of like the business route, I was still like, very, very motivated to continue on the technical route, which sort of helped me, find the next set of opportunities, which helped with the first job and consequent jobs. And, that's the path which I've chosen for myself.
So, sir, you like what I feel from your speaking that you prefer a little more practical or some experimental knowledge than rather than theoretical knowledge, right?
I would say, yeah, that's fair. At the end of the day, I would say most people, in my opinion, they learn the fastest and the most, both through success and failures by actually doing things. You can read as much as you want, but if you're not actually applying those things in a real way, in the practical world, you would never get feedback, right? So other important thing, once you get into the corporate world and start building things for real, you need user feedback, right? That tells you how to shape your product, how to build things. Similarly, when you're actually learning, unless you get the feedback of what's working, what's not working, you won't really learn. So I think, theoretical learning helps you set the foundation and understand the principles. But if you're not actually having the right kind of practical application, most likely you would never actually truly learn in a way which is very tangible. And secondly, a lot of these theoretical learnings would not stick or be even, exciting or interesting, right? So if you're just learning about, let's say, very specific machine learning algorithms, but if you don't know what you can apply it towards, right? Like it could be vision and which could be used in this autonomous driving. Once you start seeing like what actually, these things get used for, then a lot of like exciting things start to happen. Naturally, you'll start thinking about not just learning those things, but evolving them, improving them. So in a nutshell, you're right. Like practical learning has been my sort of way of advancing myself. And I think like from what I've seen in the industry, what I've seen in, during my sort of academic days, that's what truly worked for a lot of my peer group as well.
Thank you, sir. And sir, can you just give us a small brief about your professional experience, like various companies you have worked at and some interesting things about
Yeah.
that?
I started like most people, when you start your first job, you don't necessarily have a very good sense for where you would sort of become a specialist, what kind of things to really, take on and go deep in them. So you start as a generalist, right? So my first job out of college, or actually even during my college, one nice thing, and this might have evolved right now in India, but it wasn't very common back in the day. During my master's, I was fortunate enough to have done a summer internship. So I actually interned at Electronic Arts as a software intern. Ended up building, certain things as part of like a World War II sort of role-playing game, called Medal of Honor, which was fun, like just being part of the game industry, learning how to actually, build things that you end up playing later in the day was exciting and fascinating. But then, right after I graduated, sort of took up a job as a full stack engineer at Expedia, was there for a couple of years, then sort of, wanted to learn a bit more about how to build distributed services and backend systems at scale. So sort of transitioned to Amazon, which was like a great learning experience because, the scale at which even back then, like this is 2010 era, even back then, like, the scale at which Amazon kind of processed stuff was significantly ahead of many other companies. There were only a few companies which could match up that kind of scale, which was amazing crash course in learning how to build distributed systems. And I took on more key interest in building backend systems, backend services, but always had the itch. One of the reasons to move from India to US was to actually kind of dive into the world of startups. Now like India has a good startup ecosystem in Bangalore and other places, but back then, like 20 years ago, it wasn't a thing. So wanted to actually test myself in a sort of smaller ecosystem, do a lot more things from scratch. So I took on job at Spotify, which now is a big name. Everybody uses it. Everyone's sort of mom and dad and grandparents are aware of that application. They use it for streaming music. But back then, it was a tiny startup of like 400 people. It was a Swedish startup which had just launched in the US. So that's when I took on the role of being one of the two engineers working on their ad system. But that led to an interesting journey. It was one of the companies where I learned a great deal about how to build products. Because primarily, when you're a bit earlier in your career, you're told like these are the things you need to do, and you're operating more at task level. not as much at the product level, right? Like understanding how to actually engage users, what kind of metrics to measure, how to actually think about building the overall like set of features which keeps users engaged. So that kind of like learning in a real practical way, right? When the product usage sort of went up or down, and you go through these cycles, you learn a lot. So I developed an appreciation for product. I developed an appreciation for design. Like Spotify is a very well-designed application. It's very intuitive, very easy to use. So I became a lot more cross-functional. And at some point in that journey, it transitioned to sort of leading teams and running teams, transitioned into management. By the time I left, I was running all of ads engineering. And then, again, after 6 years or so, felt like I've started hitting the ceiling of what I've learned at Spotify. I wanted to try and challenge myself with yet another smaller startup. Joined a very small startup, but it couldn't quite find product market fit. So, after 6 months of giving it a try, I moved to YouTube, which was a very different experience. Again, a very reputed brand when it comes to building products, a very reputed brand when it comes to sort of having the design well done, but also operating at a scale which is significantly bigger than Spotify. When I joined YouTube, the problem was not so much of like what are the net new things we invent, but how do you continue to improve them, right? So one, like Spotify was a good 0 to 1 kind of journey. How do you build things from scratch, take it to like a good product market fit, make it work for users? YouTube was quite the other end of the spectrum. It's a very mature product. 2 billion users use it daily. But how do you actually continue to like improve and optimize things and algorithms and run experiments at scale, right? To continue to fine tune it so that people keep coming back and using the things and find the right kind of content. In my case, we were focused on giving new artists the right kind of discovery. So working a lot on search and discovery, helping them sort of monetize their content. That was a great sort of learning ground for building things at that scale and continuing to like do, a kind of 1 to n kind of iteration. But then having done a lot of consumer product app building, I wanted to test myself yet again after a few years in trying something completely new in enterprise. Because at the end of the day, right, like if you want to become like a full stack kind of leader, you need to have different kinds of experiences. How you build things in enterprise is very different from consumer stuff. Consumer, you need to have a bunch of hypotheses and run experiments to validate those things and, kind of do a lot of UXR studies. You do a few of those things, obviously, in enterprise as well. But in enterprise, your buyer often tells you what kind of things they need for sort of, the product to work on their end. So, and also this was around the time that COVID was starting to like, the pandemic was starting to end, and a lot of interest in healthcare had grown. There was a lot of like venture-backed funding happening in healthcare ecosystem. US healthcare system is very, very complicated. It's the biggest healthcare system in terms of like the revenue it generates in the world, but also it's very sort of fragmented. It's very complicated. Incentives are not aligned. So I saw an opportunity to participate in that, try and fix certain things using software, using AI towards the later half of the sort of tenure. Transition into Cedar, which is a healthcare fintech company, using a lot of AI to improve revenue outcomes for hospitals, improving like their efficiency, and did that for a little over 4 years. And now kind of I'm transitioning out from Cedar and about to go and again work for a big tech company, Salesforce, to sort of participate in and building certain products for their commerce platform. So that's been my journey in a nutshell, like back and forth between big tech companies and startups, a good mix of like 0 to 1, 1 to n products, a good mix of consumer and enterprise. So I feel like it's been fulfilling to have done, different kinds of experiences and have challenged myself, because that's the only way you can actually truly learn. Otherwise, you can reach stasis very quickly and suddenly lose, critical thinking. So my way of like challenging myself is trying something new, both in terms of domain and the kinds of problem space. So that, in a nutshell, has been my journey so far.
Yeah, that's fair enough. That checks out. So like I went through your LinkedIn page, obviously, and like as you just said, your career spans like Spotify, YouTube, Amazon, and now you're in Cedar. So like what was your inspiration behind this move from, let's say, Spotify and YouTube? They're more like consumer tech side, right? And Cedar is like health tech. So what was the inspiration for you to like transition the gap between both of these places, like consumer to healthcare tech?
Yeah, I mean, some of it is very simple, right? Like, when you're younger, cool consumer applications are a lot more exciting. You you naturally gravitate towards building things that you can use, your friends can use, you can show off at parties, you can show off, to your family. For me, like, obviously, having done internship at Electronic Arts as gaming, when I was a 21-year-old, 22-year-old, building games and showing off to friends was fun. But then, in my mid-20s, like just sort of getting to work on Spotify was an amazing thing, because it was a product which kind of appeals to everyone, right? Like music streaming had been attempted many times before, but had never been solved for a variety of reasons. But music in general, like, consumption, prior to that, there was iTunes. Prior to that, obviously, we had, compact discs and cassettes and whatnot. So music consumption has existed for a long time, but it was such a fascinating problem to solve at scale, and have access to like a universal library. Like that appealed me in first place to like just getting into the consumer product. But then as I started like working on it, you hone in on your skills, as I said, on how to actually reason about what engages the user, what kind of like product hooks you need to have, what kind of engagement mechanics you need to measure, how do you sort of monetize those things. And as you keep getting deeper and deeper and better in sort of understanding product building, the things to sort of build as an engineer for the scale, and not just the scale in terms of systems, right? But you also need to sort of think a scale in terms of the variety of users you get, because what might appeal as a content to a user of a certain cohort or a demographic background might not appeal to others. So you need to start personalizing things. To build that, you need to think about like, sort of deeply rooted user understanding systems and understanding of their presence and understanding of like, the taste profile. So like there's so much that goes on behind the scenes. And then obviously to monetize that, you need to have ad systems. So as you develop stronger and deeper understanding of these things, one opportunity leads to another. And that's what happened, right? Like that led to another startup, and kind of my relevant background experience led to my path at YouTube. But then, as I said, I'd spent like more than a decade like building these things, and wanted to sort of challenge myself, because if you think about like the industry, right, like there are a handful of like consumer apps. I'm sure all of you, if you can count on your fingertips, right, max 10 consumer apps you'll use every day, right? Like you'll use WhatsApp, you'll use Instagram, Spotify, YouTube, a few others here and there, right? But if you think about the usage of like enterprise apps across the board, as a student, or even as an employee at companies, everybody uses the Google Workplace products like the email and the Meets, Google Drive. You'll use so much like storage applications, customer relationship management software. You'll use so many other things. And to understand like the enterprise ecosystem where you can actually have a lot more usage, better monetization of that kind of user base is a critical skill set. So that was a key motivation, right? Like having spent like 15 years doing like consumer, 14, 15 years, I wanted to sort of, next phase of my journey to be a bit more enterprise oriented. So that's why like intentionality in your career choices becomes very important. And that's one thing, like, as you all get started in your careers at some point, just picking up any random job is like in the early days, sure, you can experiment, you can try a few things before you find where your kind of passion lies. But then at some point, a few years into your career, you have to be very intentional in how you want to grow and learn. And that kind of, influences sort of what kinds of opportunities, you take on.
I'll take you up on something you said earlier. You said VC funding. So like you're from a completely tech background, and then you raise the startups. So like angel investors, and then your VC funding, Series A, B, C, D. That would have been a like massive shift in your tech to complete business and investor relations background. Like you have to make pitch decks, investment theses. That would have been a completely different diverse of experience for you. Yeah.
Yeah, I mean, I did not found the company, so I was not a founder. But regardless, as sort of a leader and executive at the company, you have to constantly sort of work with your investors, do board presentations to sort of make them understand what is the strategy for each quarter, how we are executing against that strategy. Do we need to change things? Do we need to stay committed to our plans? You have to think about like how you fund different kinds of things, right? Like you don't have infinite budget to do things. And especially when I sort of transition into the startup world again in an enterprise setting, the overall macroeconomic environment around the world, as far as like startups is concerned, had changed significantly. You didn't have 0% interest rates anymore. So you have to think like the business person. You cannot just be solely focused on technology. And usually, regardless of whether you're in technology or rather whether you're in a startup or not, as you advance further in career, you have to start thinking about, holistically thinking about how do you fund different initiatives, which ones are going to pay off. It becomes a critical skill which you learn again over a period of time, where the kinds of things you do cannot just be cool things, that appear nice or exciting. They have to generate business value and business impact, and that becomes a critical metric. So I think you do acquire those skills along the way, and specifically in startups, what you have to do is you have to interface a lot with your investors and making them understand.
There's a gap between you catering to your investors and sometimes to the consumer. And like as you said, like cool company, the maximum money is made in boring companies, not cool companies. That's, I think, one of the most differentiating factors too. But on your setters page, it says that you focused on solving systematic inefficiencies in the US healthcare. So like, is there a specific, like one single inefficiency in US healthcare that kind of you completely focus your entire presence on? Like a single one which would stand out?
Yeah, so I would say, like, this is a general sort of assessment of any system, whether it's healthcare or not. You would never find, any system which is inefficient to be inefficient in one singular place. Because if that was the case, if there was a smoking gun of, yes, this particular thing is broken, then everybody would have fixed it, right? Often, any system which is inefficient has so many inefficiencies kind of, spanning end to end, depending on what the incentive systems are, what the overall ecosystem is, how fragmented or monopolistic that is, right? What are the different players and entities participating in it? So there's a lot, unfortunately, and usually that's true of any complex system. Your complex systems would never have a single point of failure. The inefficiencies kind of build up over a period of time, and often it's a game of like fixing things in smaller percentages everywhere. Now, if I was to sort of reframe your question, right, like of all the different inefficiencies, which is the one which is like, let's say, most tangible in terms of like making a difference, which you would go and attack, I would say there are several. But in the context of like how I focused on where I think technology could make a change is, the Cedar focuses exclusively in revenue cycle management. So what that means is it's a vertical within healthcare where, US healthcare ecosystem is very complex, unlike India now, where insurance industries have sort of, started growing. The US ecosystem is such that most people don't pay out of pocket, right? Like you will often have like some kind of insurance, either it's government-backed insurance or private insurance through your employer, and you still have to owe something out of your pocket as part of that contract with your insurance companies whenever you go and have a hospital visit or clinic visit. Hospitals, they obviously are a low-margin business, so whenever they're treating a patient, they will send an invoice. That invoice, will mostly get paid by insurance companies, but some part of it will be owed by patients as well. So as you can imagine, because of the inherent participation of so many entities, lack of like a singular ecosystem and standards as such, in terms of how healthcare data gets communicated between these different entities, there can be a lot of silos. So fixing those silos to bring end-to-end efficiency in ease is like a big problem statement. Now, there's a lot of work that's also happening in health and life sciences, right? Like you can do FDA drug research, you can do a bunch of like, genetic analysis. The challenge is that's not my subject matter expertise, right? Like that's a very sort of scientific research. It has a lot of kind of FDA approval backlog and processes, and it's more regulated. I found like bringing my generic technology skills to the domain where, you can follow the dollar and actually bring efficiencies is a lot more effective. You cannot solve everything because a lot of the inefficiencies are also because of the policies. But within the constraints of policy and technology can still make things a lot easier. So over the past 10, 15 years in the US, they've mandated like every health system needs to have like an electronic medical record. You cannot just have paper trail, because then everything can be digitized. You can communicate. They did establish certain standards, but those standards are not adhered to properly for a variety of reasons, which I think would be a digression for this conversation. But if you within those constraints, if you can make the end-to-end flow simple for hospital to collect the revenue, that means that it becomes much easier for them to operate, because if you can generate cash in hand for them, then they are not operating at a loss because they are often a low margin business. At the same time, if you can make the processes very easy for the patients to understand, because sometimes you still get paper statements and facts and whatnot, then you can actually make their job easier so that they don't get sent to collections. Because here, everybody in the US has like credit score and credit history. If you get sent to collections, that impacts the credit score, so you cannot get loans. It becomes a vicious cycle. So end to end, like solving that by building different fintech products, by enabling ease of understanding your invoice and bills through an AI agent was something that we felt could minimize the amount of back and forth friction and
Right.
enable the collect cash easier for hospitals, and the time for a patient to understand their bill and get things resolved without waiting on the line for a human agent could be a very tangible thing we could solve. So again, different companies are solving different parts of like this overall revenue cycle puzzle, but that's the one that we focused on.
So like optimization, basically, it's more on the optimization side. I'm going to take a massive switch away. We're going to go back a bit back. So you have witnessed the like evolution of AI, right? Like from basic, I don't know, general systems, like you said, 2010, 2005, the AI and that time, to the current like generative models of AI. So how is this rise of Gen AI like changing products as a whole on the product side here?
Yeah. So I mean, firstly, I have to say that it's not like Gen AI, which basically is a shorthand for like large language models, right? Primarily, is one of the many ways in which you can still solve problems. Like traditional machine learning techniques are still relevant out there. So it's not a quick solve for everything, but what large language models have enabled is sort of encapsulating all the information in ways which was not possible earlier because of the architecture they created. There's a lot of like feedback loop and context, but because of the scale at which these neural networks are built, you can do things at a massive scale, which were again because of advancement of hardware, TPUs, GPUs, and etc. And also like general like the overall architecture, you can capture so much information, which means things which were not possible in the past are possible now, right? Back in the day, a lot of companies still attempted to build like, let's say, a customer chatbot, but that essentially was like a rule-based engine. You would have to do so much traditional natural language understanding, natural language generation, which was prone with a lot of errors. It relied on a lot of techniques which required a lot of human annotation, and that applied even at Google search, right? Like at Google, they would fine-tune a lot of the signals, but increasingly, like as you can capture these things and encode them in large language models, it's much easier to sort of enable and unlock certain flows. So that's where you're seeing an explosion in like the AI agents dealing with customer inbound queries, AI agents even being used for making certain decisions in recommendation systems. The only challenge is like that's true of machine learning systems is as well, that it still largely tends to be a black box. But with machine learning systems, since you're kind of like breaking it down into several systems, you can still troubleshoot and figure out when things go one way or the other, and do regression analysis. It's still a hard thing to do with large language models. It's a black box, largely speaking. So as long as you can control the confines of where you're using it and have the right guardrails, it's massively powerful. But you have to like use discretion, like otherwise it can spit random sort of outputs and a lot of like results. So the short answer is yes, like it has unlocked a lot of workflows and product capabilities which weren't possible like literally 3 years ago. But you still have to know how to build systems. If you just throw random stuff at it, it will still sort of not be as valuable in terms of output it generates.
Yeah.
Sir, at least we are on the topic of building few AIs. So I wanted to ask that when you are building an AI, especially for a healthcare industry, which is basically you can say a high risk, high stake game. So, sir, what are the small strategies or testing you do, especially concerning the anonymization about it?
Yeah, so largely care, it's a regulated industry. There are a lot of laws, at least in the US, about what kind of data can be exchanged. There's HIPAA. If you're doing payments, there's PCI. Like you have to be compliant with these kind of like regulations, and you have to protect personal health information, personally identifiable information of all the users and customers, right? So none of that data ever gets used for any kind of training. You have to like, even when you're storing them in transit or actually storing them in a persistent storage, everything is encrypted with application level encryption. So that means even an employee of a company who's working with these workflows and building products, they cannot just go and look up anyone's information. Your transcripts need to be encrypted again, like when for a inbound customer query during a chat with an AI agent, you cannot just keep everything in sort of raw text, right? So you need to have like certain kinds of like security guardrails in place. Now, assuming you've done all of that, how do you solve certain problems, right? Like, so in case of the AI agent that we were building, it needs to respond to someone calling in and asking like, hey, I got this bill. I want to understand this invoice. What aspect of it was paid by insurance? How much do I owe, etc. There are certain kinds of information. Once you authenticate the user, you can extract parts of their invoice, and that's where you use retrieval augmented generation, right? So you retrieve that information from secure storage, and then sort of have the properly secured large language model reason about it. To do that, you have the right kinds of prompts built with very clear goals and objectives and the guardrails mentioned. So fundamentally, unlike a creative application where you're just uploading your picture or asking like, where do I go for vacation, where things can be a bit more loose, and the room for error is high, and the tolerance from the user is also high. With healthcare, you cannot do that. When somebody's asking for specific information about invoice, you need to truly make sure it's accurate and looking up the right information and not hallucinating. So to make sure that's truly happening on the back end, you run so many evals, right? So you have to have like eval pipelines, which are constantly looking at how accurate the information was, whether it's actually resolving the inbound inquiry, and even use large language models as a judge. So you'll have another large language model kind of replaying the scenario with the information it has and then scoring it, right? And then you would have sample responses where a human goes and actually validates things. So there are a lot of like checks and balances to make sure that the products being built can be trusted. They're not leaking information. And then, they're generally actually being very, very accurate. And in cases when it's not accurate, you go back and sort of remedy and fix the things. The challenge, as I said, with large language models is that explainability is still a bit of a challenge. So reasoning about why certain things happen in a certain way requires some smart engineering. You can log certain kinds of things and have LLM explain its reasoning. But, it's still not quite there in terms of like, a very simple if then else block where, if certain things are not working, you can go and fix the logic more deterministically. So largely speaking, with these guardrails, you can build highly regulated AI agents as well, which are not hallucinating all the time.
Now, sir, AI models or external models, it's a very big cost game. So, sir, how do you manage that big cost and latency with your model complexity? Is
Good
there any
question.
rule of thumb?
When you're starting to build out a use case, the rule of thumb is start with whatever the best model is to try and figure out, whether you can get the accurate responses, because fundamentally your objective is to get true accurate responses, right? And then you kind of like almost do a binary search of like, you can go down to the extremely cheap and fast model and then see whether that solves your problems. And if it's not, then you kind of go up and down, like, the spectrum of how complex or big model you want. Largely for latency, the faster models with fewer parameters, with as much encoded information that you need, if it gives you good responses, go for it. So in our case at Cedar, when we built that AI chatbot, we actually ended up using Gemini's Flash models, right? They're very fast, they're relatively cheap, your token costs are not that high, and it gave us the right kind of accuracy because largely we were using LLMs for composing responses and reasoning about like responses, but not necessarily encoding any information, right? They were not fine-tuned, we were doing RAG, they were actually like not trained on any specific verticalized information. So it worked out fine, but the other aspect that you mentioned is a good one. There's the latency of the model itself, and there's the latency of end-to-end system as well. So that's where smart engineering comes into practice. So whenever you're trying to reason about certain things, the amount of time it takes to fetch the information from a data store can in itself add up, right? So the techniques you do is you pre-hydrate your pipeline. So once you've authenticated a user, you can fetch all their invoice details and kind of parallelize sort of reasoning about like some kind of queries, anticipating what kind of things come next. So that reduces end-to-end latency. It largely is still like within the range that it feels reasonably okay for a human calling and not having to wait for like multiple seconds for a response. But there's always a change happening, right? Like these days, a lot of these sort of native AI companies have built like voice-to-voice models. You don't even have to do like the conversion from speech to text to LLM to text to speech again. You can just do back and forth in voice. The only challenge there is that it only works on whatever information has been encoded in the large language model. So you cannot do RAG yet. You cannot do, you can do fine-tuning, obviously, if you have your own instance, but you cannot fine-tune with regulated information because then you're breaching PHI and you're sort of, training it on critical and sensitive information. So I think like depending on your use case, you can go even faster and actually improve latency. So rule of thumb is start with something where you feel you can get the right kind of accuracy, and then kind of do a binary search on the spectrum of like high complexity to low complexity, and kind of settle down for something which gives you the right kind of trade-off between latency and quality.
Yeah, that checks out. So I'm going to take another switch over here. We spoke about entertainment tech, we spoke about health tech, we spoke about fintech. So I'm going to speak something like in this commerce, like commerce tech, right? So as a beginner, I'm a complete beginner, and when I think about e-commerce or words like commerce cloud, my mental perspective is that's just online shopping, right? What are some things that I, as a beginner, wouldn't know? Like what happens behind the scenes when you say something like e-commerce or commerce cloud? This is not just online shopping per se.
Yeah. So yeah, commerce, is largely, you're not wrong. Like commerce is online shopping, but there's a lot more to it than just that. But you have to also realize, right? Like when you build a platform, like a Shopify or Salesforce Commerce Cloud, you're not building the platform just for yourself. Like Amazon builds its own retail platform for itself. You're building a platform which requires different kinds of composable units to serve other retailers and merchants. You can have like a big retailer, building their overall online presence using Shopify or Salesforce Cloud, right? So when you're building an enterprise platform, you need to make sure that these retailers can have their overall online presence for doing end-to-end shopping or online shopping done well. But then behind the scenes, there's a lot more than just like having a website, right? You need systems like order management and inventory management so that you can actually like track things. You can do fulfillment of that stuff and ship things on time. You also need things, a product catalog feed with different kinds of pricing to be input, right? So as you see during the holiday season, the shopping season, like people have aggressive pricing discounts. These things need to be reflected in different systems across the board, both on the back end, but on the website and the storefront as well. There are things within the stores. If you go to the online retailers, if you go to a big retailer, they'll have online presence. A lot of the stuff still gets sold in brick and mortar stores, right? For a lot of these retailers, they need like point of sale application for their store associates to actually scan items, punch in things, make payments through different payment gateways. So basically building an e-commerce platform or commerce cloud entails having all these different things as offerings to any potential customer who wants to come and have like a retail presence, both online, in store, make sure like the backend systems can track orders, have inventory managed. And in certain cases also, like, not all of these things are like B2C commerce. There are big enterprises which sell to other enterprises. Think like, you could have a medical supply kind of a company trying to sell to different hospitals. They can have a different kind of portal or different hospitals to submit their bids, order in bulk. Like for instance, masks, right? You want to order like 100,000 masks or some other kind of like a medical device. So you could have like a medical mask company building up their sort of online presence where hospitals can come and purchase things. So like there's a lot that goes on because you're serving like a big clientele of hundreds and thousands of customers who are running their overall application. And the thing is, that's just the product offering. When you hit the shopping season, you want to make sure the availability of the systems is as high. Like, Amazon is known for being up all the time, right? Like, just imagine Amazon going down on Black Friday or Thanksgiving sale time, right? Similarly, like
That would be chaotic.
That will be chaotic, right? So that's the case for like some of these platforms as well, like Salesforce, for instance, tries to sort of keep its platform up so that none of its retailers and its customers being not the end users, like the people who actually run their commerce platforms on Salesforce, they have uninterrupted and successful sort of business days when you're running some of these events. So that's what goes on behind the scenes. A lot of scaling, a lot of feature building, a lot of like composability so that people don't have to buy everything. They can come and pick and choose whatever feels like the right kind of product for their offering, and then set up their online presence and even sort of store presence.
So like kind of embedding tech in their day-to-day supply chain as well as possible. That's accurate. Yeah. Then in companies like say Consumer Cloud or whatever, Salesforce, Shopify, companies like these, what are like some of the major problems that they can not take on, but like they face actually? I'd say like what are the handful of problems that they are going through?
So on the surface, you can build technology, right? But every vertical has its own sort of unique sort of demands, right? Like if you're building, let's say, an online presence for let's say an apparel store versus a home furnishing store, the way they would manage their inventory, the way they would have like certain kinds of deals run, the way they will have their store set up is very different. So like, building features and functionalities which can cater to all these verticals is very critical. And it's not like, out of the box you get all of these things. Like there's a lot of commonality and consistency, but there are several things, which are very complicated because behind the scenes, every major retailer has its own payment processor, for instance, right? Somebody uses Adyen, somebody uses Stripe, somebody uses something else. To support all those platforms is also an undertaking. You cannot just magically turn on a switch and be like, I'm integrated with this. So there's a lot of heavy lifting that goes on to make the overall experience much simpler for the customers that you're serving to be onboarded and run their operations successfully on the platform. So that's what goes on behind the scenes. And obviously, as you onboard newer customers, you want to sort of prepare for the scale you handle, have the right kind of operational sort of rhythm to make them successful, and continue to invest in new products because, when you're operating in a competitive market, you have a lot of competitors who are trying to like one-up you by building newer sort of capabilities and features. So you have to stay ahead of the competition by innovating constantly. So that's massively sort of where a lot of these companies invest as well.
Yep.
So it's more on the leadership and the scaling side now. So you have scaled engineering teams in different companies like Spotify. You said you were in early areas of Sidar and Spotify both. Sir, what is the single most or what are the crucial techniques that you feel are helping you or that helps everyone for a successfully navigate the growth in these companies or scaling a particular team?
I mean, fundamentally, right, like there are several things that go on, but the one fundamental thing is when you're building a product and you're trying to grow the business, truly sort of, having the right foundation of a clear strategy with clear objectives of what you're trying to do and being good with prioritization is very critical because often companies fail when they're trying to do too much without clarity. So I think like constraining yourself in a very thoughtful and intentional manner is very important. Otherwise, you're constantly chasing things around versus like staying committed. So that's one that almost lays the foundation for how you think about scaling and growing. And that applies not just to like what kind of products you build and how you scale those products, but also like what kind of skills you acquire, how fast you grow in terms of teams, because it's very easy to just go ahead and hire a bunch of people. But if your talent density is poor, it's not strong, then you would not execute that well. At the same time, if your teams are not cohesive and not working, that would not work well. So I think like having the right sort of guardrails and constraints and intentionality behind how you want to scale is very important. And, there are nuances to how each company operates. But largely, it sort of, everything is rallied around like what your product objectives and business objectives are. So that's the foundation. Secondly, as a leader, when you're trying to do things at a certain scale, you need to have the right kind of mindset to be enough in the weeds where you understand the critical details and you're not too hands-off because, I've seen leaders operating at very different ends of the spectrum. Some are too in the weeds and sometimes like, miss the forest while looking through the trees and they're too tactically in the weeds to actually miss out on like the bigger strategic misses and don't have the right kind of oversight at that level and can also like micromanage, which can be demotivating for the teams. But at the other end of the spectrum, I've seen people who are completely hands-off and delegate everything and do not appreciate and understand like the constraints or the challenges the team goes through because they don't quite feel the pain. The people I've admired and have tried to emulate myself after are the ones who are, at that right level of granularity of understanding the operational details, being in the weeds where you can feel the pain, you can understand the customer pain points, developer pain points, but also operating at a level of abstraction where you can see the forest through the trees and truly understand like how to plan for few steps ahead of you versus constantly chasing things and sort of being on the back foot, and also giving the right kind of autonomy to the teams, right? Like people don't want to be told how to do things. They want guidance and direction on where we are heading, what needs to be done, but how often is something that they want to control, right? So by giving them the right kind of agency and autonomy is how you empower them. And I think like that's a critical lesson as a leader where you need to find like that right trade-off, trade-off between like being enough in the weeds and delegating enough and actually sort of enabling the teams in the right way. And that's not a skill you learn overnight. You make a lot of mistakes. You see and observe others who are doing it really well. You find the right kind of mentors and learn certain techniques. You also learn from just, again, observing and seeing how others have done well or have failed. So you kind of hone in that skill over a period of time. So again, it goes back to my very first thing I was stating, like you learn the most by doing things, right? You cannot just read about these things. You'll have tons of management books, which will talk in abstract terms, but unless you've actually done it, it's harder to kind of, make advances. So that's the other thing I would say, right? So to sum it up, have the right foundation of product strategy, business strategy, which is not just like do everything, have the right constraints and guardrails, because that's the foundation. In absence of that, if your product is not succeeding, if your technology cannot enable that product to scale, and if your business impact is not materializing, none of that matters, right? Like how you think about scaling, it really has to result in that outcome. And secondly, how you execute and operate requires the right amount of like involvement in the weeds, but also the right amount of like headspace to look a bit further ahead and not just constantly be sort of, reacting to, micromanaging or reacting to situations. You have to like have some foresight to plan for things and have a little bit of like, 6 month to 12 month ahead of like look ahead planning.
Now I'll get to a little ad monetization part. So when you work at Spotify and YouTube, which are centered on ad monetization too, it's a big part of their system or the interface, if you can say that. So what are the core principles that in terms of AI also that are used for ad targeting and optimization?
Firstly, I would say that they're actually massively very different platforms, right? Like for Spotify, it's primarily a subscription-based platform. YouTube, it's more ads-based. But largely, like the way ad targeting works is that, ads are usually served at certain intervals based on different kinds of rules for how you want to engage with the users. You don't want to like, pester them with too many ads that you lose the engagement. And at the same time, like the ads, whenever you serve them, it will be mildly annoying, but hopefully like they can also like find good ads and learn about different products and purchase things. So the relevance of the products has to be really high as well, which means it starts by like actually understanding user preferences and taste profiles, building the right kinds of segments, and then targeting ads accordingly, right? So it's a massive sort of ecosystem of how these things are built. It's kind of hard to summarize it in a bit, but largely speaking, you kind of build sort of taste profiles and models for users. You don't necessarily expose them as is, but you build segments around those things. So then you build, users who tend to, watch sports and do other kinds of like activities on the platform. And what are the kind of extrapolated signals for what those things might mean to an advertiser, right? So like, let's say, in certain cases, it's very easy. If somebody's trying to sell like a cricket bat or a baseball bat, if people watch sports content or listen to certain kinds of music, right? It's very easy to sort of target those ads to them. So fundamentally, it's that, and the way algorithms work is constantly improving and evolving, right? Like there are a lot of like more classical machine learning techniques to do these kind of things, and over a period of time, like people are using large language models as well. So in a nutshell, like that's how it works.
One more thing I wanted to ask you about was like, so when you're in the tech side of it, how do you determine that if a certain video or a certain product is of which niche? Because some niches like tech or business, they have a higher CPC, higher RPM, CPM, right? But something like, say, not sports, but something fitness, that doesn't have a high RPM. That's like $3-4, but tech is $15. So like, how do you kind of differentiate between what niche it is?
The way sort of this works is like you don't try and like reverse engineer that. Like you actually try and understand what these different interests are. Like not all users are equally monetizable, right? Like that's the reality. Not all regions are equally monetizable. Like an average revenue per user for a user in the US is much higher than an average revenue per user in India or any emerging market, right? So you basically give that option to different verticals, and then they have like their sort of rate sheet of what's the standard pricing. As far as if I was to understand your question maybe in a different way, like how do you know whether a user, how do you actually profile a user? Like the way these things work is like, you just have like a user sort of vector capturing all their interests and prior sort of consumption history. In case of YouTube, it's music. In case of YouTube, case of Spotify, it's music. In case of YouTube, it's all the videos you've seen and what those videos represent. So you can have different kind of tags and labels associated with that kind of content, which basically sort of sums up your consumption history and what kind of profile you are. And once you've done that determination, right, like, yeah, you might not be highly monetizable, but whatever relevant ad could be served to you would be served to you. But at large scale, this all works out, right? Like in any given market, you'll have a good mix of different kinds of users. Sometimes you might spike in certain things versus the other. So those things obviously might influence how much a particular demographic is monetizable, right? Like sports users are not necessarily, hypothetically, let's say, as monetizable, so be it. But then at least, there are certain advertisers who would find that a lot more interesting.
Yeah. So I'm going to speak about your tech bets framework. So could you kind of briefly explain what your tech bets framework is, like investing and divesting like high risk projects, that kind of framework, what it really means?
Yeah, I mean, in a nutshell, it's very simple actually, right? Like a lot of companies over a period of time, as you build things, you're trying to ship stuff, you're trying to like deliver things to your customers, you accrue tech debt. If you don't actually reserve some capacity to get rid of the tech debt over a period of time, then system starts falling over. You don't actually are building for the future. So every company does it differently. In the case of Cedar, what I had observed was that engineers, whenever we reserve like a sixth of the capacity, like about 15-16%, to focus on clearing our tech debt, they were not necessarily taking advantage of that. The product priorities in a given sprint would take precedence. They would focus on those things, or sometimes like the tech debt projects would require a lot more collaboration across the board with different kinds of teams, because you can single-handedly not solve that. So rather than having it be free for all, I kind of created a structure where we would take the budget of 15%, a sixth of the capacity, and think about the critical themes we want to invest in a given year, right? So either like refactor our code base, or invest in events-based architecture, or the way we would run our ETL jobs for data exchange. We wanted to refactor in and make it low-code implementation pipelines. We figure out the themes, and based on whatever gives us the highest sort of value in a given particular year, and then try and solicit different projects from people of different seniority, typically staff engineers and above, to help identify what are the things we could be doing and what are the bets we want to place in that tech. The reason I used the language bets was because consistently we also use language as product bets for product investments, because what bet indicates is that a lot of these things are investments which may or may not yield dividends, but these are our assumptions and bets behind like what we feel will give us the highest leverage and ROI over the course of next year or so. So that's why, to keep the language consistent and to get people a bit more engaged, carved out that capacity and made sure that in a very intentional manner we are going and funding certain projects every year, which help us eliminate tech debt and also like invest in forward-looking systems like event-driven architecture. The divestment framework was more along the lines of that. Let's say once you've invested in a bet, and halfway through that you realize that things are not actually playing out as you had expected, right? You're not getting the desired results. So rather than just having a sunk cost fallacy and finishing the things for the sake of finishing, if you truly think that this is not going to yield results that we had expected, we would actually defund the bet and divest from it, right? Like be like, okay, our early indicators were X, Y, and Z, but our even lagging indicators of what we've built so far do not indicate huge amount of success in, let's say, reducing latency or getting to higher amount of decoupling in our code base. So let's pivot and do something else rather than continuing to like just go down that rabbit hole. So that's what kind of led to that framework of investment and divestment.
I'll ask you a personal question, right? If you don't mind. A lot of people who get into startups, right? So they have a startup, they run it for a few years, and then they pivot to something like, say, private equity or like VC funding. They join decent tier 1, tier 2 firms, which is actually it's a very good career, to be fair. So why have you ever considered going towards the managerial or the business side or the finance side of startups?
I mean, it depends on who you are, right? Like if those things motivate you, that's great. Like I'm a product builder in my heart. Like I like actually reasoning about products, building things. So, there's no right or wrong. People who do that, great. But to me, actually being sort of in the weeds of building things is what sort of generates excitement and a high amount of fulfillment. So, I've mostly stuck to, I gravitate between like sometimes doing deep technical work and sort of being on the fringes and doing a lot of product development and product strategy. I do enjoy that, but it's still fundamentally like product building, right? So I truly enjoy product building. And on that spectrum of sometimes you have to reason about what products to build, how to think about the design, how to think about GTM, you do start getting into business aspects of it. But then, and there are times when you're executing, you want to think about the architecture, how it scales. So you can kind of, go up and down in the spectrum of technical versus product strategy versus GTM and so on. But all of that is basically in the service of building things. And that's what sort of, gives me fulfillment. So I've mostly stuck to that.
So now for current days, the students are very interested, like us, or many of us, are interested in paths combining the AI, technology, and also the industry impact. And you also are from that segment kind of right now. So what are the top skills or mindsets that you believe are the make a biggest difference in that journey?
I think like, ultimately the skills are very basic, and trust me, I'm not like, just saying it to understate like the importance of that, but fundamentally start with a very easy mindset of like wanting to learn and being curious, because every day I myself and people I know who are really sort of doing wonders, they read upon so much stuff that's changing. Like with AI, every week there's a new launch, there's some new improvement. Sometimes it's hard to keep up with all those things, but to the extent you can, keeping up with those changes, learning about them, reading about them is the only way you grow, right? So curious mindset is very important. Learning mindset is very important. And then the other thing that I truly and strongly believe in is don't, and this is sometimes the mistake I made like in hindsight, right? That in the early days when I was like, 20-year-old, 21-year-old, it's like, oh, someday I'll do this, and this is an idea. The more time you spend thinking and the less time you spend doing, it's not going to help. So you learn the most by doing, and I truly believe in that. So like get started, even if it's a small thing. You don't have to build some massive new product, right? Like pick up a side project, play around with these models. And these days it's much easier. Like, back in the day, I remember we used to do C programming and C++ and whatnot. You guys can like just use cursor and whatnot and write tons of code using Python, which is very easy to sort of work with as well, and actually build projects over the weekends. Back in the day, you still had to be a pretty strong programmer to build things end to end. These days, you even if you're, let's say, strong in certain areas, like for instance, you know how to build services, but not the front end, you can still leverage AI coding tools and get started. So get started. Try and like have a mindset of doing and attempting things versus just thinking about them, and be curious. That's all it takes, because you start as an engineer. Over a period of time, by doing and learning things, you get to understand how to build products, which I kind of shared earlier. Then I learned how to sort of think about business impact. It's not rocket science, all it takes is being curious and doing things.
So, as you said about the projects and research, sir, are there any particular areas that you would recommend for students to pursue to truly stand out in the fields of AI?
One thing I would say is like, again, this is an evolution of my mindset. Don't start by wanting to stand out. Start by doing what truly resonates for you and gets you excited and motivated. You have to feel fulfilled. And naturally, as you go deep in pursuing whatever you're trying to build, you will carve out a path for yourself. You will carve out a niche for yourself where you will stand out. Standing out for the sake of standing out is foolish in my opinion. You will stand out by virtue of doing things, and naturally, like, see, the thing is, as you start executing and building things, naturally you'll try and like, get away from being a cookie cutter profile of a student who has done X, Y, and Z. You'll become that person who actually built X and started going deep in that, and that creates your own path. So start with whatever you have, start with whatever gets you excited, and keep pursuing it. That will naturally make you stand out. Like looking back, I can tell when I was a student, nothing about me stood out compared to other students. All of us had done, BE, and all of us had gone to Mumbai University. what is standing out? Nothing, right? Like you might think you are, slightly better in this and that, but like largely, if you're in the industry looking at a profile, you're a student who from University of Mumbai just pursued a BE. That's it. But over a period of time, like all of my peers now, somebody is very deep in business. I'm more of like a cross-functional product builder who does business and sort of understands business, has done product strategy and does engineering. None of that was like intentional, like looking forward. Looking back, it's very obvious. I think there's this famous Steve Jobs quote, right? Like you can connect the dots looking back, but you don't know exactly how things will work out. So start with what actually gets you motivated, and naturally over a period of time, things aggregate and you start standing out. So that was a long-winded answer, but hopefully it explains you, right? Like don't try to be standout for the sake of
Yes,
it.
sir.
Just start pushing things which resonate and give you fulfillment.
So like, what are some of the most common areas as a beginner that I can apply and embed AI and ML for product engineering purposes? Like just a common beginner's framework.
Yeah, I mean, like, you can do so many things, right? Like you can automate so many workflows which exist out there. You can start with your own personal sort of, areas where, let's say, as a student, if you have a workflow of things you're trying to do, and there are 5 manual steps required to do that. I'll give you a very specific example, right? Like I do photography for hobby. And if I want to build something right now, I take so many pictures, and then, because when you're doing wildlife photography, the animal or the bird moves so quickly, and you have tons of photo generated, but then you have to manually parse through like which one came out really good. There isn't like an easy software to actually detect that, right? Like that's a very simple workflow I can think of, where if I was to build something just for my own case or use case, and just figure out like what's the hidden gem amongst like so many different pictures, that solves my problem. But often you will find out, like when you're trying to build applications, if your problem is not so unique, and others, I'm sure like this problem exists for other people as well, right? If you truly want to pursue that, you can get started with any particular use case which applies to you. You can solve it really well and deeply for yourself. And I'm sure you'll find other people like you who are in the same boat. Then you can start actually building products. And then, whenever you're starting to build from scratch, 0 to 1, go after a niche, make it really work for that niche, and then you can branch out and start adding other things, right? So that's usually the magic. So when you're thinking about ML, AI, whatever it is, see the tools, don't choose the tools before you choose a problem. Find a problem, start building, finding the right tools. And also like the problems give you more structure, because then you can control yourself, right? You're like, this technique doesn't work for this problem, so let's try something else. This might fail after having tried, so let's try some other kind of machine learning technique. That actually gives you a lot more kind of like, room to experiment. And that's why I often say, like, once you start doing things, you will find out like Gen AI might have its own limitations in how it does, let's say, classification. So you might have to actually revert back to classical, classification techniques or regression analysis or whatever it is, to actually get to the solutions you might be looking for. And you don't necessarily have to use large language models for that, but there might be cases where those things might not work, right? So best way to explore is not starting with tools, starting with the problems, and then finding how to use the tools to actually get it done.
Yeah, fair. So like I think I can take from this that I find something that I particularly is a problem for me. I solve that, and then I find common ground with people who also probably would have the problem, because there's not anything that's particularly unique to me. People would genuinely have some problem that I'm also going through.
Exactly right. And especially when you're trying to learn things, that's a good approach. Even let's say worst case, it applies only to you, but you've still built something. Like I see a friend of mine, trying to build like a storybook using large language models for his infant kid. I mean, it might, I'm sure, applies to many other parents of young kids as well. But getting started, this person is a product manager and trying to use large language models to like just write software and build something that applies for them in itself is a good start. And then, it helps you learn and advance your understanding of different algorithms.
If you had to start and build one AI product, not Gen AI, just any AI-based product now, currently, so what would it be like, in your opinion, which is some breakthrough or something, I guess?
See, that's the other thing. I would say, like, don't start with the mindset of you want to break through or you want to stand out. Like these things, look very appealing and exciting from the outside. Often the best innovation happens by trying to fundamentally solve things. And, the lagging indicator is that it was a breakthrough or it was like something exciting. As I said, like, let's say if I want to solve something, I'll start with that very simple use case. I said, like, I have thousands of pictures I click, but out of that, like often, there are only tens or hundreds of them which are sort of, useful to be archived, because there's the real issue. I'm paying so much for my network attached storage in storing like terabytes of information, right? And that's a problem. So to reduce my cost, to manage my memory, if I can just kind of downsample the kinds of things I store, that'll be a helpful thing. And I'm sure I can use AI for that. That'll be a good learning ground for me to even figure out what kind of algorithms and techniques to use, right? So it doesn't have to be some very ambitious, lofty goal. Start with something simple, and you might learn and discover new things, because by that you might figure out like, hey, I learned about this technique for image processing, which has applications beyond like just this thing that I'm using it for. Maybe it could be used for other, and I'll give you a thinking on the spot, right? I still struggle with good image search on Google Photos, primarily because it can do few things really well. It can do face recognition, it can do place recognition. It can still large language model query, like right now if you give like a GenAI query, it can stitch together certain things and get me the right kinds of photos, but often it misses the mark. Maybe there is like a gap in the way they annotate certain things, and the metadata is not rich enough for a large language model to reason about it. Or maybe like the image recognition or certain other things, right? As you start reasoning about the things where the product fails, it naturally leads to the next question of how do I make it better, right? What is exactly missing? And once you start with that, you're like, maybe it's the data issue, maybe it's an algorithmic issue, it is something else. And that leads to sort of, more innovation. And naturally, like, that kind of answers your question, that maybe by asking that question, now you're building things which are a breakthrough innovation, which no one else has solved, right?
Yeah.
So that incremental path, right? Often things look very appealing, that, oh, there's this big bang launch. It is 100% of the times an incremental innovation, which looking back might look very breakthrough. But in the moment, people who were building and working on it, right, they were naturally asking the question with curiosity that it's not working for this case. Why is it not? And then what advancement do I need to do, right? And then they keep reasoning about it and get to a state which then is like state of the art.
This is the last question from our side. So what is the one piece of advice that you will give yourself, your younger self, when you were starting as a software engineer in, I believe, Amazon, or your younger jobs or your first few jobs?
Been fortunate enough to have had some good mentors, mid-stage career to like now, who've been very helpful because they're a good sounding board. I maybe did not benefit from that kind of good mentorship earlier in my career. Seek good mentors, and mentorship is not like people giving generic advice or reading management books and telling you things. People who can actually like reason with you about your situation, can be a sounding board as you're navigating different career choices, technology choices, whatever else it is, right? And they need to be invested in you. I think like that's a big learning for me. Later on in my career, during my Spotify days, I actually found some good mentors with whom I still like keep in touch, 10 years later, 10, 12, 13 years later. And many of those mentors are very, very helpful sounding boards for me. So I think like that's one thing that would have benefited me a lot, because, you can learn so much by just doing things yourself, but you need someone else to look at you from the outside and be like, hey, these things are interesting patterns, and these are the areas where you can do things differently, or maybe you're doing these things really well, continue doing them, right? Like that kind of mentorship is very, very important. So finding the right mentors is a very crucial area, which I would recommend everyone, right? Like, and it's not an easy one. You can find mentors, but they might not be sticky enough. Find someone who truly, you can cultivate a relationship with in a way where they are deeply invested in you and can give you good, honest opinion, feedback, guidance by truly understanding your situation, not like generic advice, because that's like, not as impactful.
That's all that we wanted to ask
That's a
you.
good way.
Sir, for giving us your valuable time for a small occasion. It was a long time, I believe, that we were planning this. I would really and I
Absolutely.
think it's done.
You're welcome.
Yeah.
Yeah. You're welcome, by the way. Yeah.